I'm from Getch Partners, and Getch Partners is not very well known in China as Getch Partners. We're recognized as GP. And interestingly enough, GP is a direct descendant firm from the office of Mies van der Rohe, which was started in Chicago quite a number of years ago. And today, we have representative offices in 3 cities around the world. Our home is Chicago, and probably always will be Chicago. But we've established offices in Shanghai, as well as in Abu Dhabi, and really have tried to attack those markets. We're primarily corporate architects that service the globe. And as we started to think about what would be appropriate for us to talk about on a Council in Tall Buildings event, obviously the idea of sustainability is a huge driver in our work today, and obviously will continue to be more so in the future. But we also need to balance the desires and ambitions for our clients and the different programs that we have. So what we identified was to select 3 projects that are in the 3 different regions that we're working in the world, and identify some of the simple solutions that marry to the architectural solutions that have an impact in a sustainable environment, but also as a functional solution that brings value to the marketplace. So we're going to look at 3 projects. One's in Dalian, China. Another one is in Abu Dhabi in the UAE. And the last one is in our hometown of Chicago. So we're going to start with the project in Dalian, which what we came to find out had a great opportunity for harvesting wind power, which of course we had no idea when we went into the project. And on this particular project, it's a hotel program. This program also has some service apartments associated with it. But the thing that was such a great draw to us was it sits right on the coastline in Dalian. And Dalian, I didn't know much about until we started working on the project. I did know that it was controlled by the Russians previously, as well as the Japanese. It's recognized as the northernmost 4-season port in China, which is just some of the things that I knew going into it. But as we started to talk, things that you learned were that the wind patterns were fairly aggressive in this particular part of the world, and sitting right on the coastline. And actually, our site is a very slender, tall, long and linear site. It obviously takes advantage of the views of the water, but it also sits off of one of the largest squares that's in Dalian itself. So we did some initial studies, obviously trying to understand the solar environment, the wind environment, the humidity levels, but very minimal at first. Really what we were focused on was trying to be a good neighbor, in all honesty. We're surrounded by a number of residential towers that are to the north of our project, and we also have a large public amenity, which is this Shanghai Square, that we really wanted to allow to still embrace the water's edge. So as we started to look at it, our long, slender site, it actually got even more slender and more long. And the orange area is really what we ended up thinking about where the tower location should start to be located as a good neighbor. And as we started to look at the tower and layer into the program, which as I mentioned is primarily a hotel program, we developed more of a triangulated shaped plan. This obviously allowed for a single loaded condition where all the rooms got to take advantage of the views out to the water. It allowed us to decentralize the core, which gave us a great stiffener in this particular program. And it also allowed us to put all the circulation for the project on the north side of the building, where that is the area that looks back onto the city and over the main square. And you can see the core is kind of a nested core, so it allows for the lower zone to drop off, and that creates this super punch that is at the top of the building. That super punch just is a reflection of the stacking of the building itself. And one of the things that we wanted to make sure was that with the circulation facing back to the city, it had a consistent aesthetic even at nighttime, so it didn't provide a sense of chaos that sometimes hospitality and residential buildings can give a certain level of chaos. But from the water's edge, this is what would be faced. The amenity is really to look out onto the water. In this case, we've actually used some sun shading devices to help minimize the solar gain in the summertime in particular. But what we really started to find was that the wind conditions in this particular part of the world became very large drivers for the structure of our building. And so even though we had already identified a triangular floor plate that would be really driven on by being a good neighbor, but also to providing views out to the water, we needed to start to study that structure as it related to the wind forces in the area. And what we found were that the original suspicions were extremely accurate, in that the average wind speeds were in excess of 4 meters per second on average throughout the year, peaking at times of 14 meters per second. And the humidity levels were extremely high. Obviously, it's a coastal environment, but the humidity in this particular area, coupled with the wind speeds, creates an incredible amount of force, and the air then becomes very strong air. It's not weak air. So as we started to understand what those forces are, we needed to start to take a look on how those forces informed our building, how we wanted to orient it as the winds change throughout the year. Since we're on a coastal environment, it's very consistent. So as we started to finalize the shape of the building, finalize the shape of the structure, we really understood that we were creating quite a shedding effect on the northeast and the northwest corners of the building. And even in the wintertime, when the winds are coming from the north and shedding across the bow of the building, an incredible amount of activity is occurring at that corner. And in the south, the building, or in the summer, in the southern times, this wind comes and it bathes itself across the long dimension of the triangles and still creates this kind of vortexing quality at these corners. And this was a particularly interesting concept because we thought that there was a potential there to actually use the wind power to generate energy for our buildings. So we actually started to look at a logical location for wind turbines that would actually be on the corners of the building. Initial thoughts were that we could get 300 linear meters of turbine there, and a very aggressive goal of over 2 million kilowatt hours per year. As we come to find, those initial estimates can be a little aggressive. But as we started to develop, we wanted to find a turbine that was befitting of the character of the site. In this case, we looked at a helix design. This helix wind design has more of a nautilus shape, which we felt was very in keeping with the kind of coastal environment that we're working on in this location. It worked in a 2-story type of scenario, and some of the things that we really cared about were that it was a constant speed, it was bird-friendly, vibration-free, so it made a lot of sense, and it's very low maintenance type of element. But of course, as we wanted to think about what were some of the other opportunities that would be regionally manufactured, it's very easy to then find other products within the Chinese marketplace that offer different solutions to the same problem. And one of the things that we started to look at then was these different products and what were their startup speed requirements, making sure that the average wind speed in this particular environment was able to exceed those requirements. What is the weight of these different turbines, and what's the impact then back on the base building? What's the total cost of the system? And then ultimately, what's the value of the kilowatt hours that they can produce, and then ultimately determine a payback period so that the owner and the investors can understand when they can get a return on that investment, as opposed to just simply contributing it back to the grid. We were able to identify that could be within 10 years that your return on your investment could be brought back in, even with the regulated energy costs that are in Dalian today. So it was an interesting little case study, in our opinion, that we went into a project where we were enamored by the site and we're working with a hotel program and a tower program, that we just wanted to simply be a good neighbor and to maximize views. to the waterfront. But at the same time, what we found was a way that we could start to generate electricity with the project in a very natural way, not forcing some type of environmental token onto the building, but have it be a development of the natural process of the project. And that's how I think we feel most natural when we're working on some of these corporate projects that we do. And then, of course, this is the state of construction where it's out there right now. The curtain wall is being tested and the shading devices are being identified. The second project is one that's on a completely different scale. And this one is in Abu Dhabi. And obviously you always have preconceived notions about what your site is going to bring to you. And anybody that's ever been to the UAE or the Middle East in general knows that the solar conditions in that part of the world are overwhelming. So we knew that going into this project, and I'd say, had the mindset to tackle that as a challenge before we even started looking at the project. And what you can see here is an early on artist rendering of what our project really is. And the ambitions were for a modern stock exchange for the UAE to become the economic center of that region, and then to surround that stock exchange with 4 Class A speculative office buildings that could house some of the most elevated corporate names in the world, and in essence start to become the commercial center for the region. This is all surrounded by, or sits on top of a man-made island connecting to multiple infrastructure projects, and but this is really the signature piece, the financial, let's say, strength behind the overall project. And so as we started to think about the projects, and you start to think about how how do you take a Class A office building which really wants to have floor-to-ceiling glass, wants to maximize transparency, wants to maximize flexibility, efficient structure. How do you start to take some of these concepts and recognize the solar challenges that are associated with this particular climate? And it became something that was very exciting for our office to start to tackle. And some of the issues that we looked at obviously were shading systems and obviously photovoltaics, which become very heavy players in this particular project. But actually there's an innovative use of double skin that I think is quite innovative and quite thoughtful in this solution. But I'm going to walk you through a couple of the different concepts for the building. So of course on the southern facades of the building, we've designed an array of passive shading devices, glass fritted elements, 750 millimeters deep, fixed on the exterior of the building, spaced so that it can recognize and deflect the solar radiation off of the primary skin of the building. Obviously, they're aligned to work with the view lines from within inside the building, but also allowing to get maximum transparency. This is a state of the construction out in the environment today. That you can see the landscaping is starting to go in. The buildings are actually starting to open up. But you can start to see the structural clarity of the building, obviously the columns being traced on the exterior of the building. But those are the passive shades that then bathe the exterior of the facade and really help to minimize that solar radiation off of our primary glazing system. And here you can see some of the corner transitions, and as you rotate around the building, densities change due to solar angles. But on the east and west facades, a fixed system really is not a sound solution. So what we actually had to do was look at more of an active solution. So these active shading elements are the same size and the same density, but they actually move with the motion of the sun and are able to then, let's say, be more intelligent of a facade as it works with the overall building, while maintaining the controls of the system in the sand-free environment behind the enclosure. And here's a recent construction shot where you can see the shades in their full closed position. However, the fritting is on the glass allows for a transparency from the interior, and you're able to still get that kind of view. I actually, in all honesty, in the UAE environment, the solar strength is so heavy that actually sometimes you feel more comfortable in this environment where the daylight is brought in, but there is actually a certain veil of clouding on the outside that allows you to feel a little bit more comfortable within the space. But the third feature was actually really associated with the core of the building. And you know, the core is obviously not only the structural backbone of the building, but it's also the engine in which most of the building breathes. Most of the air is circulated either to or from that core element, and then obviously is rejected up through and given out into the atmosphere. And one of the interesting things about this particular climate is that the ambient temperature is so hot at certain portions of the year that the air that we're rejecting out of the building is actually cooler than the ambient air within the overall environment itself. So the question to us was, is it possible actually to use that? Insulation is such a key element in creating a very strong U value for your enclosure. So we looked at studying a new type of double wall system here, and it really is the central spine or the backbone of the building, kind of cladding that core space. And what it has been allowed us to do was to mitigate the ambient temperatures, which can get up to 120 degrees Fahrenheit, versus our Class A office with with Westerners using the space who are really going to declare that it needs to be in the 72 degree, 73 degree Fahrenheit range. We can take that exchange air, that exhaust air, which is coming out in the neighborhood of around 90 to 95 degrees, and use that as a buffer between the outside air and our internal air. This also provided us an opportunity to use external shading. That external shading can be in a sand-free environment, and it can also use that shading to then keep it off the primary surface of the enclosure as well. So it was kind of an interesting way of thinking about how you use air and push air through an enclosure to combat the existing climate. Of course, in the winter months when the air is cooler, we can actually bring that air in at the base of the double wall and actually use it for a different purpose in those months of the year. But really, what you're battling is the solar radiation and the dramatic heat of this particular location. And here's a daytime shot. You can see the shading devices, the passive shading devices on left and right of the building, and in the center, the very clean zone, which is the double skin wall, which recalls the overall core, if you will, or the backbone of the building. And you can see at nighttime, this becomes a feature that is illuminated, and it really has become quite a unique application in this particular part of the world. Still able to bring a full sense of transparency, but using technology to be able to overcome that base desire for the building. And then finally, I think the one that everybody immediately associates with this environment is the opportunity to harness energy basically from the sun. And here, we didn't try to clad the buildings with photovoltaics and the like. What we actually looked at was just attacking the roof. And the roof in this situation is for the stock exchange itself. That roof is over 2,800 square meters, in essence, a football field, or an American football field. And this concept was really the idea that you can have free, unobstructed, natural solar light hitting you throughout the entire day. And simply arrayed a field of panels or photovoltaic panels about 1.5 meters up off the ground or off the primary roof surface for easy maintenance, for easy cleaning, for easy replacement, also to shield all of the conduit and the devices coming out of it. But located that on the rooftop, and then of course needed to study how this related to our speculative office developments that were around it, ensuring that it was going to get the type of exposure that we were predicting or that we were hoping for in this particular area. And the goal, and a realistic goal, is that this football field worth of photovoltaics can provide 15% of the electricity that's required for that particular building. And as you know, in that environment, electricity and energy can come at a much different rate than we get in different parts of the world. But that alone as an engine is, I think, a very high quality way to think about how you can use simple techniques just to improve the performance of your building. This is a construction shot from a few months ago. And the third project is from our hometown in Chicago. Chicago has some different issues in that land use is starting to get more and more dense, not quite like Asian density, but it is starting to become more of a reality. And our original client came to us with the desire to do a high-rise office tower, but they had a parcel of land that was valuable and fabulous within the Chicago environment, sitting on what would become Millennium Park. But they had a vision that they wanted to expand their corporate square footage, almost double in a 10-year period of time. And so the natural solution was to look for parcels of land that could satisfy an additional building in the future, but land values are extremely high, obviously, in Chicago. And so our original proposal was actually to look at the value of the air above them and actually think about doing a vertical expansion as opposed to a horizontal expansion. And the investment versus the land versus air rights actually was, it's quite self-explanatory. And so what needed to be done was design an office building, in this case, that could grow almost double its size. First phase was completed in 1997, and second phase was just completed in 2010. And what you can see here, the building is primarily a glass, stainless granite building from the exterior, but that building needed to maintain full occupancy throughout the entire construction phase. And what you can see on the left is construction as the steel framing is going up, buildings in full occupancy. And you can see that the thoughtful material selection of something that was put on a building over 15 years ago, when you use high quality materials like glass and stainless steel and stone, you're able to maintain a uniform aesthetic on the exterior of the building, and that's what you see on the right side, which is the completed project. So thoughtful material selection is critical in actually being able to achieve this. But the building story is more about the vertical expansion itself and how we did that. They had a unique desire. This is a build-to-suit building, so it's a 36,000 square foot footprint, which is a little bit larger, and they wanted some open spaces within the overall plan. So you have very deep lease space, which works very well for their particular needs. But 5 cells on the north side of the building were then carved out for atrium spaces that would run the full length of the building. And in this situation, our office elevators then are broken down into 4 zones. So as you can see, the phase 1 elevators are on the outermost zones of these 5 cells, and then phase 2 lifts would then inhabit 2 of those other atriums, and then the central atrium, of course, would be remained intact for the entire duration of the project. And this is kind of the phasing of it. So these atriums, which are amenities, bring in natural light, give you opportunities to have interfloor interconnectivity, became the backbone for how you could double a building in size. Extremely interesting concept, but at the same time, it allowed for you to participate with the elevatoring system. So as you can see in some of these images here, the elevators can go up and down through the space. It's not a traditional building in that your core is completely hidden from how you function within the project. And that gave us the opportunity to really animate these atrium spaces and to give opportunities. And additionally, the found space was quite interesting. So the cooling towers were pulled out and replaced on the top of the building. That was turned into large conference centers. Because high-rise capabilities, we were able to develop into a series of cafeteria, canteen spaces that are high up in the building, taking advantage of some of this found space and creating more destinations within the tower. And I personally love the idea that the cooling tower location previously, and now has become a large conference center with some of the most commanding views and the most sought-after rent in the city of Chicago today. And this is a completed image of the building today, which obviously fits much more fitting in the skyline, but it's a very interesting solution to a very simple problem, in my opinion. And those are the three projects that we wanted to share today.